Hey everyone, I hope you enjoyed your lunch and left some room for dessert because we're gonna eat some cake, a real one, and not so real, but I would say a Rails architecture cake. That's what we're gonna talk about today and try to compare the world of confectionery with the world of building Rails applications. So what do we know about Rails architecture? Straight from the guides, we can see that Rails follows MVC, Model View Controller principles. And that's kind of the core design principle of the framework. What is MVC? Let's quickly recall what does it mean, what the goal of MVC. Well, the idea came back from 70s, 80s, from Smalltalk world. It was way before I was born and started my software engineering journey, so that's not how I learned about MVC. I learned about MVC from this brilliant book on ActionScript programming language. If you don't know what ActionScript is, no worries. The language got extinct, but it used to be a better version of JavaScript. We built a lot of great web applications with Flash, not only games and banners, which were annoying. But the definition from this book is still surprisingly kind of hold for Rails application today. Because what is MVC? It's the idea of separation the application components into three groups by their responsibility. Model is responsible for managing state and business logic, and view class is only responsible for the user interface, nothing else. And the controller's sole responsibility is to translate user input into model updates. Well, that's probably the part that a bit differs from what we have in Rails, because in Rails, we do not have this mechanism of model updates propagated through events to view objects, something. We just have rendering. So the controller is responsible for collecting data using models and passing it to the view for rendering purposes. However, in Rails, we can easily diverge from this diagram and introduce a direct dependency of model and view, for example, or we can make controller responsible for business logic and state management, why not? And we can also make model responsible for generating some data for user interface, which is definitely not how MVC is supposed to be used. And instead of separation of concerns, Rails applications tend to unseparation of concerns. I think one of the explanations of this kind of phenomenon that Rails applications following the kind of a basic Rails way, not trying to get beyond the MVC tools we have suffer from this problem is that we only have 3 baskets to put our eggs in. Whenever we try to add some new functionality, we either choose to put it into controller, a model, and maybe views, but like, why not? Again, we have just 3 options in the stock Rails application without anything added on top of it. And that's, at this point, I want to turn into the cake and talk about cakes a bit. Whenever we cook a small cake, it's a common pattern to have just 3 layers glued together with some icing, whatever. And that's easy. It doesn't require any special equipment to cook small layers. You don't have to worry about transportation. They're small, compact, and easy. Everything is kind of simple. However, if you decide to cook a large cake and continue using just 3 layers, 3 like enormous layers, you're gonna face a lot of problems. Like cooking is complicated. Where do you put all the stuff to cook a layer, and how to cook it uniformly, how to deliver this cake and not break it. Everything is so fragile that it's going to fall apart. It's just a mess. It's not a cake. And confectioners have a solution to this problem. It's pretty elegant solution. I want to demonstrate you in this artifact we brought for everyone here in the room to share after the talk. So keep that in mind. So the solution is kind of simple. Instead of increasing the size of the layers, we introduce new layers. We cook our large cake using multiple layers, and that's it. We cook them independently. We just then glue them together using some, I don't know, whatever that is. I haven't tried yet. But this is the idea. We just scale the number of layers instead of scaling the layers themselves. Okay. So this is how it works. And that's, I would say, this is kind of beyond MVC, because we introduce more layers. And in case of software development, that's going to be abstraction layers. And that's what we're going to talk about today, about how to go from MVC to more sophisticated but efficient at the same time, which is important architecture. Okay, now an official part of introducing myself. My name is Vladimir, and I'm an ActionScript developer, and I'm building Flash applications. That I would have told you if we were like 10 years ago. But these days I'm mostly working on Ruby projects. You probably heard of some of them open sourced, most of them. And I also contribute to Ruby and Rails kind of regularly, but a bit. And you can find about my recent contribution from the Rails Changelog podcast, their latest episode. And I highly recommend to subscribe to this podcast to stay up to date with the Rails evolution, the Rails framework development, to know what's coming next versions, why, and where from. That's very interesting. That's important, actually, for our talk. You will find about it later. I also work in a company called Evil Martians. We're product development consultancy. And yeah, we build amazing tools and features for amazing clients, for amazing products. So if you want to be on the list of these amazing products, just reach out and we'll find how to help you. And finally, the final bit on the introduction is I want to say that this is my sixth RailsConf talk since 2018. It was quite a journey, and please let me know if you got tired of my talks, so I will skip the next one. Maybe. Maybe not. We'll see. But actually, I'm also tired of it, but I like it. So, okay, layers on Rails. How to identify layers. So it's easy to identify layers in the cake. Let me just do it so everyone can see it every time I'm talking about layers. Yeah, okay. So to see layers in a Rails application, we can take a look at it as a web application. What does it mean? The primary purpose of a web application is to serve requests, usually HTTP requests. So that's actually defined the nature of the application and the way we structure the code. That's drastically affect it. It's different comparing to graphical user interface application from the past, for example. They didn't have this request response lifecycle and independent units of work, which are requests. And we can picture the process of converting requests into response as an assembly line. So each workstation is responsible for each part of the work. And like we just put the raw request on the belt and pass it through the workstation, and we get a packed response and in the end. What are these workstations? That's actually our core components, core abstractions. We have a controller to accept the raw data. We have a model to do some sophisticated work. And finally, we have a view to pack it as a response to the end user. And in real life, assembly lines are meant to improve the efficiency of the kind of a product building. And whenever we change the process and make it more sophisticated, we add just new workstations. That's how we scale them in most cases. And in software development, we can do the same by adding more abstraction layers to pass our request through to, again, improve efficiency, to keep concerns separated, and while having more and more responsibilities in the code base. So in other words, the goal of this addition of new concepts, let's say abstractions, is to improve the code base maintainability, which in its turn affects productivity and code quality. Maintainability is just a kind of an umbrella word for many different characteristics of the code. But the thing is, we're not going to talk about all of them today. That's boring. The question is how to introduce a new abstraction without actually decreasing maintainability, without adding unnecessary complexity. That's the problem. Just adding some fancy pattern or fancy gem which adds some abstraction, not necessarily helpful for your code base. It could actually be worse when you introduce something new. And here, I see the difference as a game of Tetris. When you add random abstractions just, I don't know, because you want to add something without doing proper analysis, without trying them to feed the application, the complexity actually piles up until the game is over. Your code is very maintainable. You just introduce a lot of stuff which doesn't work well together and doesn't fit well together. So it makes things worse. But adding a good abstraction, I'm going to use this term, good abstraction, which is maybe not the best definition, but we'll use it as an abstraction that actually decreases the complexity. It hides common patterns from your code, generalizes them, and makes it easier to use particular features of your application to implement them further. So you can actually continue to stay productive. So let's talk about how to come up with a good abstraction for Rails application. And for that, I prepared a recipe. So I'm going to give a few ingredients. We're going to talk about them in a bit and then see some practical examples. First, what is a good abstraction in general? Again, it carries many features. First of all, abstraction, by definition, is a kind of encapsulation of some internal logic and providing a high-level interface to access it, right? So that's kind of we can remove it. We also want to make our abstraction layer having maybe not single responsibility, but a few related responsibilities. So like we do not use controllers instead as models, for example, right? That's a different responsibility completely. We don't want to mix them. And a lot of other stuff, like I would like to focus on testability a bit because I think it's one of the most important ones for productivity, as well as readability and usability and so on. Okay, there are many ability words. But for Rails, we add one more characteristics, which I think is actually the most important to make our abstraction play well with the framework. It's using conventions, relying on conventions. And that's kind of dual property. On one term, when you introduce a new abstraction, make it conventional. Introducing a convention with this abstraction. It could be naming convention or whatever. So there are multiple ways to do that. But another thing here is that try to make your convention at least non-orthogonal to what Rails provides. Ideally, follow just the Rails conventions on naming APIs, classes, whatever, to make new abstraction look like it Rails, like it belongs to Rails. That's kind of just an idea that follows the principle of least surprise. And from a practical point of view, so the first ingredient is following Rails convention, following the Rails way, actually, because what we're going to do, we want to extend the Rails way, not to change it, modify, break, whatever, and build something on top of it. We not rebuilding here, we kind of repairing our Rails application on top of what we already have. And from a practical point of view, that means learning how Rails work. That's the most important thing. Because if you don't know how Rails works internally, it's hard to come up with a similar level of abstraction and similar interface and similar ideas that's going to fit together well. So learning the framework is required for this kind of operation, for this recipe. And also reusing Rails building blocks like active model, active support tools is also an important part of this. Because that would naturally lead to the APIs interfaces similar to what we already have in Rails. The second ingredient will tell us where to put our abstraction on the assembly line, because in the layered architecture, every abstraction and the layer and the abstraction layers, so every abstraction has its own place, right? Like an assembly line. That could be branching, that could be some kind of maybe even loops, but still there is some dedicated place for each abstraction. And for that, I would refer to the layered architecture principle, which is a different concept from abstraction layers in your application. So, but it's still related. It's more kind of an architectural design pattern. It operates concepts on the macro level. It's not talking about particular abstractions, but it talks about group of objects or components you have in the application. And it implies that you separate them into horizontal layers and allow each layer depend only on the layers below. That means that if you have a presentation, which is kind of the most important separation of presentation from everything else, then domain model, like your models, they should not rely on entities from the presentation world, for example, like request objects or some HTTP information or whatever. They should operate only on your domain. That would naturally decrease coupling, so and make your code more maintainable. And speaking of presentation layer, as I said, that's kind of the most important part. So the presentation layer is the one that interacts with the end user. It's the one where you have a concept of user and user request or UI. So it's responsible for both handling requests and providing the interface. So in Rails, it's going to be controllers and views. They're all from the presentation layer. They should be there. And that helps to avoid even some bugs, especially in Rails application. One common example of when violating this principle leads to unexpected behavior is passing action controller parameters down the stack. They quack sometimes like a hash, but they're not. And if they eventually ended up in your model and you don't know that it's action controller params, and for example, you check for some method or even using isA, instance checking, class checking, you may end up with unexpected behavior you don't want. And converting presentation layer entities to something from the application core is one of the best way to avoid some kind of tricky bugs in the system. Another thing that layer architecture provides is the concept of closed and open layers, or the restrictions on how deep you can reach from your layer, how deep could be your dependencies. So for example, on this slide, we have kind of a custom version of layered architecture where we allow presentation layer to access application level and domain level, but not infrastructure. Infrastructure is where we put all the implementation details like database adapters, API clients, everything related to how exactly, in this particular moment, we deal with data usually. We can go all in and use all closed layers. That would mean that every layer can only access the layer below it, but not further down. And that's also a concept I see sometimes even in Rails application. And you can see it as every controller has some kind of an interactor object, even if it's just does model save, but you still add interactor and then you call model and all. I think that's too much for Rails, actually. So being so strict and layer separation, because it leads to a lot of boilerplate, and it's going to be hard to compensate this added complexity by introducing this pattern. So that's where I think we barely adding anything to the system and maybe even making it less maintainable, at least from the productivity points of view. So that's just ideas. We're not gonna go all in, DDD, domain-driven design, and start doing that for Rails, no, but we still can use ideas from this paradigm. And that idea gives us a separation of our abstractions depending on which layer do they belong. And the most important thing here is that one architectural layer may contain many abstraction layers. That's normal because it's a different concept. But each abstraction layer, your code abstraction, must belong to only single architecture layer. That's what's important. And if you have, for example, models, and if some of your model is responsible for generating like CSS classes, it kind of becomes a member of the presentation layer, actually. And that violates this principle. And you probably know why this is not really good. So you need to introduce something, maybe new abstraction, and just move out this code in the view layer to deal with it. Let's do some quick example of trying to use layered architecture principles to figure out which layer does an object belong to. So here we have authenticator class, some kind of a object which is responsible for getting a token from request right now and returning a user. How do you think which architectural layer does this class belong to? You can go out loud. Okay. Yeah, that's correct. We rely on the request object. A request object is from the presentation layer. So we already depend on it. And if we depend on it, we cannot be lower than this layer. However, there is one interesting point. We also rely on the infrastructure layer. Here we know the source of the configuration, like Rails secrets. It's not just a random configuration setting. We directly refer to the source where we can get it. And that makes our object also accessing infrastructure layer. And if we rewind a bit and remember the diagram with the arrows on it, we didn't allow presentation to access our infrastructure layer because we want to limit the visibility for each layer for how deep it can go. Otherwise, it will lead, again, to high coupling. So this object is not a good abstraction. I would turn it into an application-level object which only cares about dealing with tokens and returning users, but do not care where we get this token from. So we can reuse it with other presentation methods, other inbound layers like controllers, channels, WebSockets, whatever. We can use it everywhere. And that's an example of the kind of a rule or theorem I made up to describe how to detect where the object belongs to. You just take a look at all the inputs and dependencies, and the layer of this object is the highest level of all its inputs and dependencies. That's it. And that will tell you where actually to extract code. So that's where we got to use it. So that's the second ingredient, layered architecture ideas. Not principle, just ideas. We can use them, not strictly probably, but still refer to them to think about abstractions. The final ingredient will answer the question how to choose new abstractions. Where is the catalog of abstractions I can choose from? Where is the 5-star abstraction everyone should use? But the thing is, in order to create a good abstraction, you should replace this question with another one, how to extract abstractions. Because artificially adding abstractions usually comes at a price, because adding concepts to your application always increase conceptual complexity. We can't avoid it. And that means that we only can add new concepts to fix existing problems. That's how we compensate the price we pay for that. And if we just introduce abstractions just because everyone uses it, for example, that would make code base less maintainable. So extraction is kind of there are some ideas on how we can approach extracting abstractions. Just take a look at the more complex code, use some analysis tools to churn complexity analysis. My go-to tool for that is Tractor Jam. So I recommend to take a look and start analyzing the code. Try to use layered architecture principles and see where the parts of the code should belong to and try to generalize and extract further. So that's a recipe. It's just kind of a very abstract. Yeah, we're dealing with abstractions. Now let's go do something real. Some extraction. Give me a second. Okay, so the first example, we're going to deal with webhooks. So imagine that we have some application which tracks GitHub activity for our users, and we want to keep track of open pull requests and issues. Just a random example. So how would we implement it in Rails? I think I would start with the following. We have a controller where we part the data, incoming request, get a hash out of it, do some digging into to figure out the login of the user. And that's one of the interesting part of the format of the GitHub webhooks, because the login is always in a different place. So we have this fallback, it looks like a code smell, right? But yeah, we can start with it. We on Rails, we're starting with building things faster, and they're going to work. And then we find a user and invoke the method on the model. So here's the model. Here we again do some pattern matching to extract the information depending on the event type. And it kind of looks good. What's wrong with it? In my opinion, this part is wrong because the event object is not a part of our model. It's modeled in the third-party service. We do not control it. We don't know anything about it. And we make it a dependency of our model. So that would actually mean that our model is kind of trying to escape the domain layer. Let's fix it. And to fix this one, we don't need to introduce any new abstraction layers. No, not yet. That's not that fast. We can just extract a model. We can build a model in our domain space to represent the GitHub event, add a mapping functionality for it. It's going to be kind of a combination of a mapper and a model. But we are okay with keeping it in a single place for now. And do some data normalization. We no longer need to worry about where the logging lives. We can just do that at the mapping phase. And then we can use it in a controller and pass this domain event object to our model. Here, we no longer have this hack around extracting logging from different places. So the code is much cleaner. And in the model, we also deal with model domain objects we have full control of. So it makes testing easier. We don't need to think about this GitHub event hashes or JSONs at many places. We just want to create pure Ruby objects that represent this data. So even such an abstraction within the same layer, extraction within the same layer, increase our maintainability. But that's not the end. I would ask another question. We, as every Ruby Rails developer, we decided to put this logic right into the user model, because why not? Like, user is the only model which can take all the responsibilities, because we're humans, we're strong. So, but that's probably not the best way to keep the code base maintainable. We all heard about God objects and all that stuff, and have you ever seen a 10,000 lines user RB file? Yeah, I saw recently. I could believe it, but yeah, they exist. Anyway, let's figure out. We can move this code somewhere, but the question is where? Where should we move this code? Well, I can ask the audience probably again. Maybe next time someone will be loud and yield the answer. Where would you extract this code? No. Okay, no jokes. Yes, you're kind of correct, because this day we ask language models such questions, and language models are always telling us the truth, right? So that's the truth. We need to extract it in a service object. Nice. That's a topic I like. Okay, service object. Really, like, why I didn't mention service object yet, right? Models, controllers, view. We all know that there is a hidden abstraction in Rails called service objects. Everyone's using it. So service objects. I added it to the diagram, but a bit different visualization, because service object is an interesting topic in the Rails world. We even had some dedicated talks on this subject. But I would say for our purpose, when we want to craft a good abstraction layer for Rails, service object just doesn't work. Because it's not an abstraction layer, it's just a kind of a mechanism of extracting code. We don't even have a common definition of service object. It could be everything from pure Ruby objects to interactors to monadic something, blah, 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 dry, whatever. So service object is just a term we use to a way to put the code. Oh, put it in the app services. Yes, where else? Like, we kind of started thinking in folders instead of thinking in abstractions. And instead of having a finite number of abstraction layers, we have n abstraction layers for every service object in our folder. That's drastically increase conceptual complexity, first of all. Of course, some people try to standardize them. It couldn't work at the beginning when you have a few of them, like a common interface, even result objects. But then you find that, oh, they need different type of behaviors because they play different roles. And they start to diverge from each other. So it's hard to come up with a common interface. Doesn't mean that I'm kind of advocating against using service object idea at all. That's not what I'm talking about. I would rather consider a service object actually to play a very important role in this process of extracting abstractions. They could be used as an intermediate step before the final abstraction emerges. I see service objects, app services folder as a waiting room. So we have some code there. We just wait for the next abstraction to emerge in your code base. Because extracting right away something like building something conceptual with some ideas when not having enough use cases, not enough scenarios in your application when you need it, could lead to bad abstraction. So service objects help us to avoid starting early with abstraction and let us keep code in the folder and let it age for some moment. Because generalization, a good generalization, which is a property of the good abstraction, requires some aging. You cannot just come up with the idea out of nowhere. But at the same time, you should remember that service object is still not the best way to model your application world and rules and operations or whatever. So just try to analyze them and come up with, group them into abstractions as the application grows. In our use case, we can go with a pure Ruby object. Even this extraction would be helpful. Our controller no longer knows about user. That's great. That reduce the churn for this file. We don't need to modify it pretty often. Everything is moved to the service object. We simplify testing because we don't need a lot of setup. We just check that we call the correct service object, and that's it. And the service object itself just encapsulates this logic, and we can further operate with this only class. I don't know where it could lead as application evolves. We probably have more webhook-related functionality we would like to extract into proper abstraction. I would suggest taking a look at the workshop that's happening tomorrow on building webhooks on Rails. There, you will learn about particular abstractions that are useful for this use case. Let's move on to the final example. It's again about models, and this time forms. So we add a bit of interface. Models are not kind of an accident here in every example because in Rails application, we usually put a lot of stuff into models and make them over-responsible. Here we have an invitation form with one field and one checkbox, sending a couple of emails, and creating a user. Let's start with basic Rails way implementation using just models and controllers. So here is our model class. It might be not the very basic example because we have some virtual attributes here, not the thing everyone's using, but that's the way I would like to control when I want to send the email notification. But the thing is, and that's the most, I think, controversial conclusion of using layered architecture ideas in Rails, that calling mailers from models should be prohibited because mailers are from the upper layer. They're from the application layer. Your domain should not take care of your business operations, especially like notifications, not a very kind of important stuff. They should go somewhere upper the architecture stack. Yeah, that's hard to convince Rails developers to avoid using that kind of things in models. But we have some options to offer. And as I said, we have a virtual attribute. And the problem with this virtual attribute is it's actually very context-specific. Likely, we added it exactly for this feature related to a particular interface, user interface form. So it has nothing to do with the domain model of this entity. It's just a hack we added to control the behavior of the notification. So using our second ingredient, I would say that this functionality should go somewhere upper application layer. Let's go to controller. So in the controller, we have another interesting place. We check for the checkbox for the send me copy like this. And that's an example of actually leaking abstraction, because this way we leak in implementation details of the Rails forms, how the checkboxes are implemented, why it's one or not true or yes or whatever. Imagine like someday your CTO decided to rewrite everything in React and they use different concepts for checkbox and everything will just blow up. So that's not good. And another problem is that we actually now spread the functionality of single kind of a business operation into two parts, two places. We have something in the model, something in the controller, and that's just not good. I wouldn't work with this code. I would like to fix it. And it's better to localize this logic somewhere, at least its entry point and steps required to perform the operation. And since we're dealing with form, the thing that comes into mind kind of naturally is using form objects. It's a pattern. Let's start with a form object pattern, which form object is responsible for handling and verifying user input, transforming it probably into application language, and invoking some business level operation, and probably side effects. Sometimes developers insist on adding rendering responsibility to form object as well, so it's not only for handling requests, but also to render forms, but I would say that's too much. The primary purpose of the form object pattern should be just handling the form submissions. And rendering could be a bonus, but not the important part of it. So let's start with extracting a form object to implement our feature. And we can start with a pure object, pure Ruby extraction. We don't need to introduce anything fancy. We can just write a Ruby class, add some information to it from the parameters, add a method to kind of persist this form, to submit this form, and everything else. So we kind of localized all the logic related to this form into a single place. And that sounds like a good idea. That's a good step. But let's take a look first at the form itself. We have here some hackery again related to typecasting. We have to, we cover more cases, but still it's kind of something that should belong to somewhere else. Especially imagine if you want to reuse these ideas for different forms. So we need to abstract this functionality somehow. In the controller, you also have some smelly parts. First one is how we deal with parameters. So we try to use the existing Rails form, like form for user for the invitation, which we used before. So we kind of gradually introducing new things. And user don't have this send copy attribute, and we don't want to add a virtual attribute, right? We decided not to do that. So we just define it at the top level, and now we have to deal with two sets of params, and that's, I don't know, barely readable syntax. And another problem that in case the submission fails, we want to re-render a new action with a new template, which actually relied on user object to render the form. So we had to expose the internal cell form object and do this hack. And I would say this abstraction is not making our code base more maintainable. It's actually add more hacks than it fixes. How can we turn it into a good abstraction? Let's list the common tasks that we want to solve for form objects. So the abstraction is defined by the set of common tasks, could be defined by the set of common tasks it solves out of the box. So that's where we hide the complexity by providing higher level interface for this particular use cases. And for form objects, such use cases are handling inputs, converting it, validating, and another one is triggering some side effects on submission, like we have sent email notifications. And also we want this Rails-specific compatibility with the Rails layer, a Rails view layer, like view helpers, more precisely. And to achieve this, we now go to the first ingredient, and we're going to use Rails conventions and building blocks. We have everything, actually, in Rails to implement this, mostly in active model and active support. Let's see the final form in action, how it's going to look. So this is our form object. Now we have a DSL backed by active model attributes API to define form fields and their types. So typecasting is solved by the framework the same way we solved it everywhere in the code base. Then we also have the standard entry point method for all the form objects. We can later use it in other abstractions, for example. So if we know what the method name, we can rely on it. We also have callbacks, which is, why not? Callbacks not always bad. We use them to extract kind of a peripheral logic of our form into separate steps. And now we can read that this form contains these fields, and after successful submission, it triggers a couple of notifications. And that's how we use it. Oh, sorry, wrong slide. Okay. And that's how we use it in the controller. Now, instead of a user object, we just use this form object, which kind of quacks like a model because it's based on active model. And it could be interchangeable with the Rails model, pretty much. We don't have to deal with parameters mangling, with, I don't know, any other hacks. And we can even use it with form helpers, like a regular Rails model. That would require a bit of magic. I will show on the next slide, but that's possible and that would work. So we make our abstraction fit well with a whole Rails kind of a stack. And that's the core of our abstraction. That's the place that hides complexity. So again, as I already said, we include active model, some extensions. We define callbacks. We also, by the way, fix the problem we had in the original form object. We now make it transaction aware, because the original form didn't care about sending emails even if it's wrapped in outer transactions that could fail. But now we can fix it at the abstraction level, so like in the core of this feature. And users should not care about this anymore. They just have after commit and after submit callbacks to deal with it. And finally, this bit is responsible for action view compatibility. Yeah, that may sound cryptic. That's probably we should make a pull request to Rails to make such modification easier. But it gives us compatibility with action view layer if we follow the convention, because we have a convention of naming forms. If it's an invitation form, then we expect the path, the road, to be invitations. So it's kind of an invitation resource. And finally, we have an interface, which is not implemented in the base object. So that's the process of crafting a good abstraction step by step, first by identifying kind of a pain points using some layer architecture principles. Then we just extract code, do the same process again, and analyze whether it's better or not. And then we try to make it Rails-ish and turn into an actual abstraction which we can reuse later to create more such objects. And that's not the end of this process. We can continue with making our form objects work, for example, with strong parameters, because right now we have a bit of duplication. So our form already defines the parameters it accepts, but we also define them in the controller when we call require, invitation, permit. We can probably solve this by moving this into the form object itself. That could be helpful. And we can improve developer experience working with our forms by adding some maybe test matchers, test something, whatever, and generators for your application, so we can easily generate new forms and the test for them. That's also part of Rails, actually. It's part of Rails developer experience and productivity, making code that writes code for you. So that's was an example of this recipe in action. There are many actually questions left. For example, can I use something not from the Rails to build my abstractions? Sure. Like with any, again, culinary recipe, it's okay to experiment. It's okay to diverge from the recipe, change ingredients, see what's going to happen, and if it's good, just fix it and like add the notes on top of it. Yes, I'm always trying to use whatever works best for the job, right? We can use a lot of great tools in the dry-RB ecosystem. If we pick them individually and combine with Rails in mind, that sometimes is very beneficial. Another question is how many layers is enough? It depends. It's an obvious answer to this. But I would like to show some example from several projects I worked on where we ended up with the following layers. And yeah, there are probably many of them. That much more than we have in this cake, right? And I promised you that this cake is really good. I'm not sure. But it has just 5 layers. My favorite cake looks a bit differently. Unfortunately, hard to find this one in the United States. So we have just a minute, and I have just 2 slides, and then we start eating. Okay, final thing. What's missing from this talk? A lot of things, because this talk is just 40 minutes, and to better reflect on these ideas, I had to write a book, the whole book on exploring the extended Rails way. So the way of introducing new concepts, new abstractions into Rails without diverging from the Rails way. So to stay productive as in the beginning, but be able to handle the code base evolution. It's coming someday this year. And that's pretty much it. Thank you very much. Enjoy the cake. Ask me for stickers and for layers and for questions. Thank you.